Welcome back to our video classes, and I am Anik with you again. And today we are going to discuss about the 10th. Hello, everyone. So, hello, everyone. Welcome back to our video classes, and I am Anik Ghosh with you, your chemistry teacher. And this is the second last video of language of chemistry. So, I think you are focusing on the chapter and you are just watching my videos and what I have made earlier. Okay, if you have any doubts, you know what you have to do. You just have to, write it on the forum. Okay, that's it. So today we are just going to discuss about the characteristics of chemical reaction and how to balance a chemical reaction. This is a very simple topic, but still it needs our full attention towards this chapter, because both of them are very important. You are going to learn this balancing of equation today, and after that this is still going to be in your help when you are in class 10th, 11th and 12th as well. So this chapter, this part, this subsection is very much important, is going to be very much important for you. Okay, so please pay attention over here, and don't if you have any doubt, please write it on the forum. Okay, we will definitely get back to you. Okay, now the thing is, today we would start with the characteristics of chemical reactions. So what are the chemical reactions? So if you have gone through the last video, I have already discussed about all the characteristics of a chemical reaction. Today also I would discuss about some of them, but it is already done in our last video. So what are the characteristics of a chemical reaction? So a chemical reaction, it was a word equation, isn't it? After that, initially is a word equation, isn't it? From there, from there, we got the symbolic equation. We got the symbolic equation. Yeah, isn't it? So this was the thing that we did in the last class as well. Fine. So first the word equation, after that the symbolic equation. So the word equation is something like that, like magnesium uh, plus oxygen and so on. So I am just writing the entire words to describe the reaction. That is the word equation, isn't it? And now, what was the symbolic equation? Do you remember? Like magnesium has a symbol of Mg, oxygen has a symbol of O2. Together they are making MgO. This was the chemical equation, finally. Now, what are the speciality about this chemical equation? So when you write a chemical equation like that, you get to know about so many things, isn't it? You get to know about the physical state of each and every reactant, because when you're writing a proper chemical equation, you have to write the physical and the physical states of the reactant. In that way, the proper chemical equation should be written like MgS O2G gives us MgO S. So a solid magnesium with a gaseous oxygen, together they just mixed up to give us MgO, which is a solid, which is like a ash, white powder, isn't it? So this was the entire equation in front of you. Now, so an equation helps us to find out the physical property of the reactant. What else? An equation is showing you the arrowhead. The arrowhead. I think you remember what was the essence, what was the effectiveness of this arrowhead over here. It is showing that it is showing that these two guys over here, they are the reactant, isn't it? And this is the product. Why is that? Because the arrow is showing you that the reaction is moving from left to right, right? So the reactant would be in the left side of a reaction. So these are the reactant. They are mainly reacting together each other with each other to give you MgO, isn't it? So that is the reactant, and these are the products. Fine. So and the arrowhead is showing the direction. This is showing us the direction of the reaction, isn't it? It is showing the direction of the reaction. So this was about it. So I think you have got it so far, right? Now, the thing is, this was all about a chemical a reaction and what are the characteristics of a chemical reaction. So there are some more things, some more detailed thing which which are needed to be discussed. But definitely we would come back to that after we complete this balancing of chemical equation concept. Okay. This balancing is very much important. I have already told you, and today we are going to see some. First, I'm going to teach you how to you would be able to balance chemical reaction. After that, I'm going to show you a very cool video which we can see over here. This video is really very understanding, and this video is made up with very good concepts over there. Okay, it would help you a lot. Okay, now how to balance a chemical reaction. So first, what is the need of balancing a chemical reaction? So what was the need what was the history behind it? Why are we so much concerned about balancing a chemical equation? So the speciality about it is nothing but the law of conservation of mass. Okay, forget about the dogs, those are barking. I know your attention is there, right? The focus over here, law of conservation of mass. Okay, now this law of conservation of mass is teaching us that the law in the entire world is constant. Okay, just give me a moment, let me just tell you about it. What is happening in the law of conservation of mass? The law of conservation of mass is showing us that if this is a pen, okay, if this is a pen, then what would happen to it? If this pen is reacting, if this pen is participating in a chemical reaction, then what would happen? We would get a product with the same mass. The mass of this pen would never, if this is like 2 grams, we would get the product of 2 grams only. Okay, the mass can neither be created nor be destroyed in a chemical reaction, right? So that was the thing we learned earlier. Okay, now the thing is, you can see over here, that is the thing, that is the basis of this law of conservation of mass. So the thing is, the mass is neither be created nor be destroyed. So to maintain that only, we need to balance the chemical reaction, because the mass of the reactant, the mass of reactant should be equals to the mass of product, isn't it? If they are just equal, only then the law of conservation of mass is satisfied, right? And if the law of conservation, so that is the main target behind it. Okay, so we can say the number of atoms for reactants, okay, number of atoms for reactants should be equals to the number of atoms for products as well. Fine. So number of atoms of the reactant should be equals to the number of atoms in the product. So we just need to keep that thing in mind. Okay, we just need to do the reaction in such a way that the left side and the right side, there should be an equal number of atoms of each and every, like all the atoms would be equal in both the sides. That is what you have to maintain. Okay, and if you can do that, that is only the law of conservation of mass is, it is the law of conservation of mass is kept there. Okay, it is like the target, it is our target, right? It is our target to make the both the masses equal. Okay, so now Let's just try to think about it. Balance. So what is the way through which you'll be going to understand like how to balance a chemical reaction? Okay, what is the way? So if someone gives you this question that you have Fe plus H2O gives you Fe2O3 plus H2, how to balance this chemical reaction? You need to balance this chemical reaction. Fine. To balance this reaction. Then how to balance this? How would you be able to do that? So there are a few steps that you need to follow in order to find the exact way to balance this chemical reaction. Okay, the reaction is Fe plus H2 gives you Fe2O3 plus H2. Fine. Now they're saying that draw boxes around each formula and don't make changes inside the boxes. So first thing is, first write the entire thing again. Okay, Fe2O3 plus H2. You do it with me, okay? You just do it with me. Don't just look into the video, just try to write everything, because this part is all about applications. Okay, so you need to understand, because I'm going to teach you step by step for once only. Okay, after that you need to do it. Fine, I have so many questions after that. You need to solve those questions, so please pay attention over here. So first thing is, draw some boxes around them. Fine, like that only. And they're saying that do not draw boxes and don't make changes inside the boxes while balancing. You cannot touch these boxes balancing a chemical reaction. Fine. Now, list the number of atoms present in the unbalanced equation. So now what you have to do is you have to make a list. You have to make a list between the left hand side, means the reactant side, and the right hand side. Okay, you need to keep a track on the number of atoms over here. So let's do it. So how many irons are there? So I would start with iron only. So how many irons are there in the left side? In the left side, you can see there is only one iron, isn't it? And the right side, how many irons are there? There are two iron. We are talking about the atoms. So in the left side, there is only one iron atom. But in the right side, there are two iron atoms, isn't it? Just look into it. There is only one atom. And here you can see Fe2. Fe2. What does it mean? Means two Fe's are there. Okay. So in the right side, there are two iron atoms. Fine. In the left side, there are, let's just consider the hydrogens again now. In the left side, there are two hydrogen atoms you can see over here. And the right side, there is two hydrogen. There are two hydrogen atoms here as well. Okay, fine. Now oxygen. On the left side, you can see there is only one oxygen, isn't it? But on the right side, there are three oxygens. So you have just to make this list. Now I think it's very much clear, like where you have to walk. You can see that hydrogen is already balanced. The number of hydrogen in the reactant side and the product side is already same. So you don't have to work on that part. What you have to do is you need to balance the iron and you need to balance the oxygen. If you can do that, then the overall reaction is balanced, isn't it? So start balancing with the compound contains maximum number of atoms. So just start with the compound containing maximum number of atoms. So if we just go back to our reaction, which compound is having maximum number of atoms? No doubt Fe2O3, isn't it? So we would start with Fe2O3. Now we would start with Fe2O3, isn't it? We'd start with Fe2O3. Now let's just look into it. There are two iron and three oxygen. There are two iron and three oxygen. So what you have to do is you have to make 2 ions on the left side and 3 oxygen on the left side. Okay. Now in order to do that, what you can do is you can write 2 on the left side. So the thing is you need to make it. I'm just writing it again. Okay. So LHS and RHS. Okay. Fe2O3 is on the right hand side. So I am writing start first Fe. Fe2O3 is on the right hand side. So there is 2 and there is 1. Okay. There were hydrogen as well. So hydrogens were balanced, if I am not wrong, 2 and 2. Okay. The oxygen was 2 and 1 and 3. Okay. The oxygen was 1 and 3. Now we need to balance this entire thing. There are 2 ions here and there is only 1 iron in the left side. How to make them balanced? What should I do so that they would get balanced? Definitely I'm going to multiply 2 with it. Then definitely both of them would get balanced. Okay. When I'm trying to multiply 2 with iron, what I have to do is in the reaction, what I have to do is I have to write 2 over here. So let's just write 2 over here and let's see what is the new equation we are getting. Fe plus H2O, 2 Fe2O3. This gives us Fe plus H2O, Fe2O3 plus H2. Now, the first step shows us that multiply 2 with it. So just multiply 2 with it. Okay. So now the thing that is happening is 2 Fe. Okay. And 2 Fe. So iron is now balanced, isn't it? The iron is now balanced. Fine. Fine. Now we would move on to oxygen. So let's just check out on oxygen. So now what is happening for oxygen? There are 3 on the right and 1 on the left. So to balance it, we have to multiply 3 with it again. Now, so in order to do that, just write 3 here because I need to multiply 3 with oxygen. Okay. But in order to do that, what is happening is 3 is also getting multiplied with hydrogen as well because we cannot help it. That is a overall compound. We cannot help it. If 3, I need to add 3 for the oxygen, hydrogen is automatically getting involved. But that is not a big deal. That is what I'm trying to tell you. That is not a big deal. So if it gives you 6, you can also come back. So just let's just use this all these things. Okay. So second thing. Okay. The thing is we are trying to balance the chemical equation. Okay, I have already written it. 3H2, I have already written it. Wait for a moment. Yeah. Yeah. So iron is balanced. Hydrogen, this is getting worse anyways, and oxygen is balanced. Fine. Now what would happen for let's just write it again. So we have 2 Fe plus how many H2O? 3. Okay. 3 H2O gives us Fe2O3 plus H2. Okay, let me see. Yeah, so this is the equation right now in front of us. Fine. We have 2 Fe, we have 2 Fe balanced. We have 6 hydrogen, we have only 2 hydrogen. The hydrogen is not balanced. We have 3 oxygen and we have 3 oxygen. The oxygen is also balanced. So now only the hydrogen is not getting balanced so far. So what you have to do is How many hydrogens are the left hand side? There are 6 hydrogen atoms. To do something to make the right hand side equal, so what would you do? Would you just multiply 3 with it, isn't it? So just write 3 over here. The equation is balanced, isn't it? Just look through, just go through it for once. You'll be able to see how many carbons, how many oxygens are there. So you can see not carbon and oxygen. So how many iron and how many oxygen. So you can see in the final equation we have over here. Okay. So the thing we can see is from the left hand side, Fe, there are 2 irons, and the right side as well, you have 2 irons. In the left side, you had 6 hydrogen and 1 oxygen. Okay, and the right side as well, you have 6 hydrogen. Yeah, 6 hydrogen and okay, 6 hydrogens are there. What else? 6 hydrogen and 6 hydrogen. So hydrogen is also balanced, and 3 oxygen and 3 oxygen. So 3 oxygen is also balanced. Don't just write like that. Okay. Don't just write them together. Just wait for a moment. Yeah. In the left side, you have 3 yeah. In the left hand side, you have 6 hydrogen over here. You can see it. In the right hand side as well, you would have 6 hydrogen. Fine. And oxygen is also getting balanced. So this is how you need to balance a chemical reaction. Got my point? Now you just try to solve these questions in that manner only. The way we have discussed the things, you just try to solve this question one by one. Let's just start with the first one first. Zn plus H2SO4 gives us ZnSO4 plus H2, isn't it? Okay, before just coming to the practice part, let's just go through the video first. Okay, it would make your understanding better with it. Let's see the video. So you can see that's trying to show you a tug of war where there are 3 people who is using one side in the one side there are 3 people, and another side there is only one person. So this is not an even thing, right? So to make it even, to make it symmetrical, one needs to go that side, right? To make it symmetrical. So now it is balanced, isn't it? Now it is balanced from both the sides. This is how you need to make the chemical equations balanced as well. The law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. That thing I was trying to tell you. Now, if someone tries to create a mask, to break this law, let's see what would happen. So if you are creating some mass, what would happen? Okay, creation of mass. Now when you are creating mass, so it is not allowed. Chemical reaction cannot make right. Chemical reaction cannot take masses. So we cannot like they cannot generate mass or they cannot destroy mass as well. So new creation of mass is not allowed in the chemical reaction. Fine. And deduction of mass, he has he has left the rope. The deduction of mass is also not allowed. So the mass has to be the same only. Fine. Now you can see in a chemical reaction, mass cannot be created nor be destroyed as well, isn't it? Nor be destroyed as well. So let's just consider these boys are the atoms of the reactants. Like the way the atoms get combined with each other, similarly the boys are getting combined with each other. And yeah, so that's it. Let's see. Yeah, some of the examples we are coming to that, but let's see what are the examples they are trying to show us. So you don't know, you don't need up to this. So that was the thing. Okay, I think you have got it. Got it so far? Fine. So state the balancing with the. Okay, it's okay. It's done. Now coming to this part. Okay. Now you have to try doing this question, the question number 1. Okay. So what is happening in the question number 1? Zn is getting connected with SO4. Okay. And this is a displacement reaction and hydrogen gas is being evolved. Fine. This was a irreversible chemical reaction, right? Now the thing is, when I try to balance this equation, okay, this was the reaction. This is the reaction. Now what you have to do is you have to balance this chemical reaction. Fine. Now how to balance this chemical reaction? Let's see. So first thing is done. Okay. So the thing that you have to do is you have to make some boxes around it. Got my point here? So first we are just making the boxes over there, right? First we are just making the boxes over there. After that, what you have to do is you cannot change the things inside the boxes. Fine. What you have to do is now you have to calculate, you have to count the number of atoms on the left side and the number of atoms on the right side. So let's do that. LHS, how many zincs are there? 1. In LHS, how many hydrogens are there? 2. How many sulfurs are there? 1. How many oxygens are there? 4. Now in the RHS, what is happening? Okay, in RHS, what is happening there? We have 1 zinc here as well. We have 1 sulfur here as well. We have 4 oxygens here as well. But we have 2 hydrogens here as well. So you can see both the reactant and both the products are already, they have already balanced each other. Okay, fine. Okay, so now this is how you need to solve this question. So you don't need to do anything. This is already pre-solved question. Now try to solve the next question, NaOH plus H2SO4. Fine. So NaOH plus H2SO4. Let's see how to do this equation. So the products are Na2SO4, okay, plus H2O. Now let's see how to solve this question. Fine. Now NaOH plus H2SO4. Let's see. The first thing is make some boxes around it. Okay, now look into it. Now let's make the list. LHS. Okay, so LHS is just like this. Now you need to write all of the things. There are two hydrogens, there are one zinc. Fine, let's wait for a moment. Okay, so the thing is, yeah, in the LHS, how many sodium are there? One. How many oxygens are there? Two. How many sulfur? Okay, sorry, one. Only here, isn't it? Yeah. So these are the okay, oxygen is left. Okay, five. Fine. So this is the LHS, and what is there in the RHS? Now, in the RHS, you can see there is one sodium. There are two sodiums over here. So write it like two. There are hydrogens are two. Sulfur is one, and oxygen is 415. Fine. So LHS and RHS are already written. Now you what you have to do is you need to make them equal. So you can see 5 is completely matching, 1 is completely matching, another one is completely matching, but 1 and 2, okay, 1 and 2 are the making the difference. So you just add up 2 with it. Okay, so what would happen? The new equation would be like okay. So after putting 2 over here, 2Na plus H2SO4 is giving us Na2SO4 plus H2O. Okay, so now this is the equation. So is everything balanced now? 2 sodium, okay, 2 sodium, 2 hydrogens, 2 hydrogens, okay, SO4, one SO4, another SO4. So everything is getting mixed, right? Right. Now let's just solve this question. So I think you can see like let me see, sodium 2, sodium 2, SO4, SO4, 2, 2. Okay, fine, fine. So yeah, this is how you need to balance this chemical equation. Fine. Now you would be trying to solve the other two questions. Okay. And if you don't be able to do that, then please come back to the forum and ask your teachers to let them solve and give them this question so that they can solve it for you. Now let's just go back. Just wait for a moment. Now, I think you can see this PPT over here. So we have covered each and everything. Now you just go through these PPTs. Okay. Fine. You just go through it. You'll be able to understand each and everything. There is no such thing important written over here. This is how you need to balance the chemical reaction. This is already for the tell me for what, for chemical balancing the chemical reaction, in which the reactants and the products are denoted by the respective chemical formulas. Okay, so a chemical reaction is a symbolic representation. Okay, a symbolic representation. So as I told you that there are so many ways through which you can denote a chemical reaction. It can be a word equation, it can be a symbolic equation. So symbolic equation is the best way to describe a chemical reaction, because there are the states, there are the direction, each and everything is represented. Okay, and we have already completed this part. Okay, so you just go through this and try to solve this balancing part. Okay, and we would definitely meet in the next class with the answers to those questions. Fine. So that's it, and you just keep on learning from Ask IITians. If you have any doubt, just write it on the chat forum. I'll definitely get back to you. Thank you everyone, thank you everyone for your attention. We would definitely meet on the next class.